Okay. Hey Eric, good to see you joining us. Okay, I'm gonna start with a little jam, and then we're going to explain about all the different features of the product. This is the first time that I'm talking about this and like really talking about all the details, so I'll do my best to be cohesive and structured. We're also going to look at the build itself. I'm going to go through the soldering and the steps to build one of these units, and talk about the community membership that we just launched, which I think is super exciting because I'm sure that we're going to come up with really interesting new ideas, new instruments in the very near future. So let's get started. I'm just going to jam around a little bit with string and effects, and we'll take it from there. Feel free to ask questions and chat in the comments. I am alone. There's no moderator, so if I'm taking a minute to reply, I'm sorry about that, but I'll do my best to reply quickly. Okay. For people who are not familiar, this instrument string is designed around mutable instruments rings. Mutable instruments is one of the most interesting and most innovative designers in the Eurorack community, and one of the main leaders of open source. The reason that we're able to have these beautiful sounds is because they were super generous to allow everyone to use it. We're adding a bunch of functionality into this in the hope to expand and add to the open source community. In this particular instrument, what we have is some distortion that is added on the fader right here. And of course we have touchpads that in the Eurorack module do not exist. And then we have the functionality of the ring vibration or damping here. So let's take that distortion down. This is a damp string. It's a more vibrant string. And then in the timbre here we can change the overtones, which will allow us to create different timbres. This, if you look carefully, is connected to this knob. So in the design here, we sort of modulate and add more complexity into the timbre sound by adding this knob. Brightness. Okay, and then we have another, basically an arpeggiator here. So if I play and I turn the switch up, let me see, if I'll turn the switch up, then, and let's turn this all off, then now I have an arpeggio. It's not latching because this is not latched. So if I push this all the way up, the knob here allows me to control the arpeggiator or the melody maker. It's a bit more of an advanced thing. It's not really just an arpeggiator, because we could have different kinds of rhythms here. These are different Euclidean rhythms. And what I can do here with, if I hold the T right here, you can see that there is a little dot here. That's because these are also touch sensors, and they are connected internally into the touch sensor that you see here inside. That means that if I hold T and I push here, I speed up my clock, or I slow it down. You see? Sometimes, yeah, still in development, so sometimes I need to restart it, but so this. And what I can also do is, if I speed it up a lot, then I can create these kind of interesting performances. Now, this knob right here allows me to add some randomness to the damping. So if I would do this, and this is all the way off, then you can see how it's basically changing this fader for me. It's modulating the fader. Okay, now another thing that I can do is, so that I have an arpeggiator here. It is now only playing the notes that I gave it, but it can also play more notes if I turn this knob up. So it randomizes on the scale. And the more I bring it up, more notes are going to be added. Yeah. Yeah, so this is basically this string firmware. I need to give some credits here. So this design, I worked with Vlad Litvinenko on this. He's the developer behind all the different examples and instruments that you're going to see today, and a lot of the work that we have on GitHub. He's also the one that organizes our GitHub and really keeps everything modular, structured. So thank you so much, Vlad, for all the work you're doing here. Let's have a look at how we integrate effects into this. So I have a note here, and it is connected from the output right here into, let me zoom out, into the effects unit. And in the effects unit we have, first of all, different kinds of distortion. So let's say that I play something like this. I can now press on any of these pads to add different kinds of distortion. What I can also do is I can hold and I can change the volume of this particular distortion, because as you may know, distortions change in volume depending on whatever you feed into them. So if you're going to connect the guitar here, you might need to adjust it differently, or if you're going to connect different kinds of synthesizers, depending on the input, you'll need to adjust the volume. sort of like analog distortion. And these are bit crushers. So this one, this one, and this one are bit crushers. And that's cool because I could do all sorts of stuff like this. Or I could put two of them together, or three. Or I could, of course, switch and then it will latch. So now I have this effect constantly playing. Okay, another thing that I have here, and maybe let's turn off the effect. I can add delay. I can also add reverb. So this is the size of the room. This is the input of the reverb. And this is the mix. And I can modulate the delay time. So maybe turn off the reverb. And it's basically doing up and down on this time fader. And this is the speed of this modulation. This is still something that we need to work on, but it's still getting a bit noisy because it actually goes into audio rate. Yeah, so this knob still needs some adjusting. Nevertheless, it can actually sound pretty cool. Still discovering the possibilities with this. now on 100% delay. So we're not really hearing the input clean. And if I'll turn off the modulation, you can hear it simply just repeating the delay. At this point, it becomes a bit noisy. But I don't know, maybe you guys can explore this and discover some things that I didn't. If you have any questions or you want me to test a certain thing, please let me know in the chat. It almost sounds like a bowing now. Crazy that this little thing can do so much weird shit. Back in the day when I was playing guitar on stage and stuff, I would love the, what was it called, the DL4 from Line 6. Man, I was like messing around with this thing so much that at a certain point I just put it on a table and I started playing with it on a table instead of on the floor. Now pretty much everybody's doing it, but back then it was kind of weird, especially in jazz clubs in Toronto. And at this point, I can just like add or like change the notes. Maybe take down the amount of notes playing. Maybe bring the frequency all the way up. And let it sing. Yeah, the delay modulation, there's a lot to explore here. Going for too long, maybe. Let's turn this off. Okay, let's break things down, right? So, first thing first, let's zoom out. And what I want to show you is how this thing is built. What are you actually getting in the package? When you're getting a package, you are actually... it depends what you're getting. If you're getting a built unit, then this is what you're going to be getting. And this unit has all the faceplates on it. When you receive it, this faceplate in the back is not... Let me just see the focus here. Is this now? Yeah. This faceplate is loose. Depending if you want to put it in Eurorack or not, then you can put it in or not. And then you're going to have the string firmware installed and the string interface or faceplate installed. Now you're also going to get the base faceplate. This is this one. We did not play this one yet. And you're going to get a blank faceplate. And the way that I use blank faceplates is with Posca pens, these pens right here, because they can actually dry fairly quickly and they won't change. So if I want to make some sort of a design, I can draw, well, draw with ADHD is drum. So draw, and like after a couple of minutes it will dry and it will stay. So this is really nice if you are going to use one of our different firmwares from the website, you can just draw the interface on it. Or if you're a developer and you're coming up with ideas and you want to test out some ideas, you can draw with a Posca pen. If you just put a bit of alcohol on this and you clean it, it will go off. Yeah, so that's that. And you obviously also get to the effects faceplate. So you have 4 faceplates: effects, string, bass, and the blank one. That's that. Now let's have a look quickly on the website. Okay, so you should see the website now. The new thing, let me just maybe get this here. The new thing that we have on the website now is, well, first of all, you can go here to touch 2, and you're going to see all the information on the product. And if you want to go and see the firmwares, what you can do is let's do Command T and get to GitHub. So on GitHub, we have all these different repositories, and the one interesting that this stays here. Yeah, that's Arc. Arc is cool. Okay, so yeah, Simple Touch is the repository you're looking for. And if you're going to go into DaisyDuino, you're going to see touch bass, touch drone, drum machine, effects, looper, slicer, and string. Each of these has all the code right here. If you're familiar with GitHub, you know how to work with this. At the bottom, you have here the sort of like a little manual that Vlad worked on to make sure that it's a bit easier to work with. But I would love to make this a bit or much more refined. So this is something that we'll have to work with people in the community to make the documentation better. So if you are listening to this and you want to help out and you want to help like with our GitHub or documentation, please reach out. The binary file right here, you can click on it to download it. And once it's downloaded, you can go to the Daisy Seed web programmer and you can connect right here. And maybe I'm going to show you quickly how this is done because some people were struggling with it. I'm going to connect my unit right here. And I'm going to press boot. So this is this button right here. Let's maybe zoom in. This is boot and this is reset. So boot, reset. And if I go to my programmer now, if I press connect, it'll show me Daisy Seed and DF mode. Let me see. Yeah, okay. This is what it should show. So I pressed again boot reset and it says DFU in FS mode. I click connect and then I can go to choose file and touch string. That's the one that I just downloaded. Actually, let's just take touch bass and open that and then simply program. Now you'll see it's erasing the DFU device memory. It'll take a couple of seconds. And you can see here, done. So if I'll now connect to the output, right, so this is still the string faceplate. I'll need to put the bass one on and then you'll see that you have here oscillator A, oscillator B, A plus B, or A. So this is like a mixer basically for A and B, and this switch is going to control that. More on that later on. Here we have the filter and the envelope and the pattern, which is also that melody maker that we had here as well. These are the same. Let me see if I have any questions. Feel free to ask and I'll get to it. Let me see. Zammerts, thank you so much. That would be amazing. Reach out to me. You can send an email to Roey, R-O-E-Y, at synthux.academy, or reach out on Discord and we can do that together. Okay, so let's continue. I'm going to... So far, makes sense? Everybody understands the whole idea of how to flash the firmware from GitHub? Because if that's the case, I'm going to clean things up here and go into build mode. Oh, maybe before I do that, I wanted to mention the new membership that we have. So if you click here on membership at the top, you're going to get to the membership page. And of course, everyone on Discord and everything that we do on YouTube, everything's completely free. All the open source programs that we're releasing on GitHub, this will always be free. However, many of you asked if you could support the nonprofit. We're a nonprofit organization and we're working super hard. Many of us, most of us are not making any money at all. To be honest, all of us are not making any money at all, even for our hours, because we will need to sell way more units to get to a point where we actually are sustainable. So we now added a membership. Perhaps too late. We should have done it earlier because already I think 8 people subscribed since we announced it just like a day or 2 ago. I think yesterday we announced it. If you get the core membership, first of all, you're supporting the initiative, and this is huge because it allows us to allocate more time, which will mean more content and more awesome stuff, more firmwares, more, we all want to do this, but we need to somehow pay for food for our kids. So that's the first thing. Although it's the third thing here, it's actually the first thing to think about. The main thing that you're going to get is the master classes and courses. So if you're going to click on this, you're going to get to here. This is 2 fantastic master classes from Nick Donaldson from Infrasonic Audio. These are from Vlad Litvinenko. And when I mean that the money that goes into this is going directly to support the educators, these are the people I mean, and hopefully we're going to get more people from the community. So again, if you're interested, if you're a developer, if you want to dive into education, this is the place to get started and build something awesome. So these are the masterclasses and courses, and you're going to get access for a full year, unlimited. And then there's going to be community-only offers. This is also really exciting because all these faceplates that we're releasing, like the bass and the string and the effects, these are going to go, we're going to expand on these. We're going to have more firmwares. We're going to have more instruments. And these are going to be on a really special discount for all community members. We're also going to have all sorts of merchandise. If you know already the designs that we have, these are by students of mine from the Design Academy in Eindhoven, and like a lot of different things that we're doing here. Everything is done pretty much by the good love to creation from all the artists and designers and engineers working on this. So yeah, all this stuff is going to be available for community members or core community members. Okay, yeah, let's get to the build. I'm just gonna check again if we have any questions. Good, let's get started. When we get one of these kits in the mail, we get a box. It's a box with a bunch of things. The reason it's a box like this is because I feel like, you know, it is more plastic, but it's less plastic, I think, because you're not going to throw this as a trash. You're actually going to use it for something, like keeping some components. There are actually some extra components you get here. So this is just a good way to keep everything organized. You're going to get the Daisy Seed. This is the beast of a microcontroller that we're using to run all the different firmwares. You're going to get the touch sensor, this one. I wish my camera would focus a bit faster. And you're going to get headers. These are the headers. We're going to also get potentiometers or trimmers, switches, and we're going to get jacks, faders, some spacers or standoffs, and 5mm bolts. These are limited edition keychains. Focus. Yeah, these are keychains, but they're also 1U size, so you could also put them in your 1U Eurorack rail. And we're going to start with a couple of things. Let's maybe get a board. And I think we're going to make Zemmer, thank you so much. I think we're actually going to make like goals. There is actually a creative goal that I need to announce. From next week, we're going to start doing live streams every week, and these are going to focus on a theme. And the theme is going to be for this month. That for June, it's going to be bass. Vlad is going to join. He's going to explain the whole architecture of the instrument, of the bass instrument, and then we're going to allow you to ask questions and see what kind of ideas you have about your own firmwares, your own bass instruments. So let me. So the idea there is to make, so the goal for the year is to have 10 more firmwares at least. That means 10 more instruments. How awesome would that be? So as a teacher, I know that one of the main challenges that people are facing when they finish school or the academy is that they don't really have a focus. They don't really have that weekly meeting with a teacher, and they don't have the end term goal, like I need to build this within half a year. So the idea of having these kind of challenges is to sort of focus us and let us have this space to really focus on something, like saying, I'm going to build something this month. It's going to be hacky, it's going to be weird, but I'm going to put the efforts into it. And if we do it all together, and some of us professionals and teachers can support you in the process, I think that it's going to be really fruitful for everyone. So we're going to have these challenges, more on this next week. But for now, let's just focus on the build. what we have here is the board, and note that I actually flipped it like this, so you have all these female headers, and you can see that it says no soldering on this side. You do not solder on this side, unless I tell you. But what we're going to do is we're going to cut one of these female headers, and then, so this is basically half, and then we're going to keep these ones full. We don't cut them. And then what I do is I put this on the table, on the edge of the table, and I push it up, and now I can start to work. Look at this shiny thing. Let's just, this is going to be distracting. I'm going to press on this button to make it a bit more focused with the light, and I'm going to zoom in. Look at this fancy live stream. Okay. I have a soldering iron here, and you can see that it's on 320 degrees. I don't know if we'll focus on this. Can you focus on this? Yeah, you can see now that it's really shiny. This is really important when you solder. I don't know how many of you soldered before, but it's really important that your soldering iron is actually fresh and wet. Otherwise, the solder is not going to stick. I'm going to put one soldering joint point here and one here. And then I'm going to put another one right here. It actually did both. That's nice. And here. And note that when I do this, I also press on the board, and then I lift up my soldering iron. The reason I do this is because I want to make sure that the female headers are connected, are flush to the board. So now let's do this edge. Press again, lift it up. This is a pretty cool hack. I can just put it in the middle here, put some solder, and it actually goes sometimes on 2 pins. Okay, so now I'm pretty sure this is straight. Put one here as well. One here as well. And now if I turn it to the other side, I can see that they are flush to the board. Everything is really straight. Nice. Okay. I can now continue to solder the rest. If you have any questions, feel free to ask. Note that I am soldering first of all the left side, so like this and then this. This is just out of a habit. It actually doesn't really matter. And I'm always pressing a little bit when I'm soldering just to make sure that, again, that everything is flush. I can now turn around to the other side and solder here. The reason I turn around is because I don't want to fill in these holes, but to be honest, it doesn't really matter. These are connected internally. The reason we have them like this is because this is a prototyping board and it allows us to like bridge things if we wanted to, or if you would want to connect maybe another microcontroller like Raspberry Pi. Some of them are just a bit bigger. They're like 2.54 millimeters wider, so you can actually put the board like this. But if you do, you do need to cut the bridges. Bridges, like you see these things, they're like little bridges here inside. So you can actually cut these bridges. These bridges are a connection to each of these components. So when you are using a different microcontroller, again, talking about sustainability, trying to make a prototyping board that allows you to work with different microcontrollers, Arduino, Tinsy, Raspberry Pi. Yeah, when you're designing with sustainability in mind, you're trying to make things work with lots of different things. So you have an excuse to not throw this electronic board to the trash, even in 5 years' time, or even longer. Okay, so this is done. I have now everything connected, and I can double check again that it is flush. That's good. Let's see that all my connections are good. Maybe I'll turn on the light a bit. Yeah, so what I'm looking for is to see that there are no connections that are bridged. Like there's no connection between these. Each of them is separate. This is not a problem. Like I see here, this is fine. But I just want to make sure that nothing is shorted. Like there's no, like 15 and 14 are not connected together. Once I did that, I can solder my microcontroller. And let me see where it's here. Okay, so let's just open this bag. And this is the magical Daisy Seed by Electrosmith. It doesn't have headers on it, and we actually only need, you can see that this is a bit longer than the Daisy itself. So one side is a bit longer than the other. It's almost identical, but the side that's a bit shorter is going to go into the microcontroller like this, and the other side is going to go into the board. And you see that there are 4 extra pins here, so I need to break 4 out. I'm not doing this with my hand, but with a cutter. Okay, like this. I'm going to do it also on this one. It's so hard to look at the screen when you work, but I'm managing. Okay, so this is going to go like this on the board. And this is going to go like this on the board. Again, the longer side, the tiny bit longer side, is going to go inside the board, and then the microcontroller is going to go on top, like so. Now, maybe turn off the light a bit. Now, I can press this in, and note that I put my thumbs here, I put 2 fingers here. I'm trying to press on this together, and this can be quite hard, so you might want to stand to just have full support and be straight. So you're going to hear a click, like that. Okay, This is obviously not soldered yet. I'm going to start by soldering these two pins right here. So, yeah, I'm used to it, so I'm trying to explain everything that I do. So I actually put my finger here, and then I press with a soldering iron here, so they're balanced. I'm balancing the board like this, and then I put some solder on the soldering iron, and I wait for the solder to melt and go on into the board, and then I lift it up. I'm gonna make sure that I'm pressing so the board stays straight. Again, flush. I'm going to do the same thing here. And now I'm going to turn to the other side and do these two. Cool. Now I'm gonna check that it's flush. Light. This is looking very good. This is looking very good. This is what we want to have. Really, everything is flush. So now I'm going to turn to this side and I'm going to solder only this side. Then I'm going to turn it and solder the other side. And the reason for that is I never want to cross solder on components that are super fragile. So let's do that. If you're not sure how much solder to put in, I hope that in this video you can see the amount that I'm putting in. I can also show you light. See if I can get it to focus. So something sharp. You see this kind of like little pyramid? This is the amount of solder that you want to have. This is maybe too little. These are better. Not that this is a big deal, this is also fine, but you don't want to have too much, and you don't want to have too little. This is maybe, I'm just going to add a bit of solder here. It is going to work, and if you look carefully, you see that I keep my soldering iron just a tiny bit right after the soldering on the pad, and this simply allows for the solder to melt and go inside of the hole. That's what we want. We want the joint to be really strong, and we do that by keeping it for a second so the solder flows into the hole. I don't know if any of you experts have ever worked with a microscope to solder, but I found it so hard. I really need to look at it on the angle. I don't know how people do it with a microscope. Okay, yeah, this will do for now. Now, I want to show you how to take it out. First of all, because we'll need to solder something under. And second of all, because these pins are really fragile. The pins that we just soldered. So if you take it out, you need to be very gentle. The way I do this is I use a screwdriver, a flat screwdriver. I put it under and I lift it up very gently. I don't try to press too hard. I go to the other side and I try to do this here as well. Then I go back and I hear a click. And there you go. It's out and all the pins are straight. Please focus. Hello. So you see that all the pins are straight, none of them bent. These are really thin. The reason that I'm using these is because it just makes the board much, much lower. Everything is very close. Yeah, it's just nicer to work with, but it does come with a price. So these are not very strong. So just remember that. Okay, I'm now going to put this right inside my box, and I'm going to take my touch sensor. For the touch sensor, I'll need also to do the same thing. So I'm going to have my pins right here. I see that I need this amount. Like that. And I'll need also this amount right here. So this is 12. That's looking good. So same thing here. We're going to put the bottom part here, top part right here, and then have the touch sensor like that. Again, press so again, balancing, soldering, pressing, same thing here. Turning to the other side. Any questions? No. Good. Am I talking to myself? No, just a few people. Cool. Okay, so now let's solder these. Turn to the other side. Very good. We have now our touch sensor connected, and this is by far the most complicated part in this build. It's a really easy build, so we can now continue with our potentiometers. These you'll need to bend a little bit, so I'm just gonna press on these pins like that, and I'm going to place them with 3 legs at the bottom like this, and then the 2 right here, so it's going to be standing like this. let's do that. There we go. The reason that we need to bend them is because these footprints, as if you have some experience, you might be able to tell. You can put different components on them. So these ones, their legs are 1 millimeter, and these are 2 millimeters. So these will also fit here. Well, this I took one that was used before, but yeah. So this will also fit inside. It's so hard to work with a camera like this. There we go. Yeah. So this will also fit here. They're not part of the kit, but again, because we're using these to come up with all sorts of different ideas for instruments, this allows us more creative freedom. We can also put one of these jacks that comes with your kit. Again, this is more of an advanced thing, but if you anytime need to do that, then you could do this. You could put a jack here, or yeah, a jack, that's a mono jack, or you could put a switch in the middle. So all of these, they actually connect to the same pin. So this is like S31, and you'll see in the code that it's connected directly to the pin here on the microcontroller, the S31. Yeah, okay. Better bedtime stories. Yeah, I guess this is sort of like meditation. My voice is also getting so low when I'm talking to myself, which probably helps as well. Just don't fall asleep. Okay. I hope that this video is going to make it easier for everyone to build their own kits. But if you do have questions, you know that you can always reach out on Discord. We have access to Discord. It's completely public, but you need to just click on the website. Like if you go. If you click on the community button right here, it'll take you to this form. Just fill in the form and it's going to send you directly to Discord. Yeah, okay, so we have now the potentiometers. We're now going to also add our jacks. These go right here. Like that. The board is designed in such a way that they won't fall, they will stay in place, which is great. The faders, depending on how their legs are bent, they might fall a bit. So what I do is I just give them a bit of a bend here, because I want them to stay in place when I turn it to the other side. This just makes it easier to solder afterwards and keep them flush. So I'm gonna put this hole here. and then pull a little bit. Now it's flush to the board, just like here. See, on both sides, this is looking good. Now, before I'm going to solder anything here, I'm going to take one of the face plates, and I'm gonna put it right here on top. Oh, I forgot one thing, sorry. We need to take one of these guys, so one of these pairs. We have here the spacer and the bolt. The bolt goes from the back, spacer goes from the front. You don't need any screwdriver for this. Just put it like this and put the faceplate on top. Now you'll need another bolt. And here you can use a Phillips screwdriver to tighten it. You can put your finger here to sort of hold it in place. And now you know that your faceplate is in place. And the reason that we do that before soldering is we want to make sure that all the components can actually move. We want to look carefully that you can see here that this one is a bit pushed, so I can still move it because I didn't solder it. This one is a bit pushed, so I can move it. And when you buy a built unit, this is the stuff I need to do to all of them to make sure that everything is aligned properly. Okay, so then I turn it to the other side. I'm going to double check again that the faders are flush. And you'll see that I do this quite frequently, because I want to do the work once. Something that I learned when I started doing things that are a bit more engineering was that engineering needs to be really precise. If you make a mistake, you're going to pay for it. So what I'm going to do now is I'm going to solder this point here. And then I'm going to check that it is flush. And it's not. So because I have only one pin soldered, I can warm it up. I can press on it a little bit. And then I can press on the other side, make sure that it's flush. And then solder only one pin, only this. Then I'm going to turn to the other side, double check that it's flush. Perfect. Now I can solder this one as well. I wish my camera would focus just a little faster. Okay, this is good. This is now good. I can check the other side. Again, it's sort of moved a little bit in place, so I'm going to push this a bit up. Gently solder one pin, check that it's flush. Very good. What type of solder do I use? Let me show you. I'm using this. It's less toxic. Doesn't have. Yeah, it's made in Germany. Stanol is a really good brand. This one is just great, and 1mm I really like it. It's a bit thicker. A lot of people prefer thinner ones like 0.7 or 0.8. I like this one. Been using it for quite some time now, also at the Academy. Okay, so this is now done. The faders are done. I'm gonna check again that my potentiometers are aligned correctly. If they are not, I'm gonna move them a little bit. And then I'm gonna turn to the other side. Solder only the 3 bottom pins. Okay. Now again, let's check. This is looking pretty good. I'm now going to solder the additional pins of each potentiometer. So these ones. I start from all the left ones. And then I go turn it to the other side. And I have all my potentiometers and faders connected. Now I'm going to look at my jacks. Jacks again should be flush to the board. Let's just connect these first. Check that it's flush. If it is, let's solder the rest. Please focus. Hello. Focus. Nothing. Okay. I don't know why it's not focusing now. Okay, we're pretty much done with this. What we need to do now is to take this header, and we're going to use this here for Eurorack. We can cut off one of the pins because we actually need only 5. So 1, 2, 3, 4, 5. Take out one. And we're going to connect it right here. You can see here that it says plus 12 volts, ground, 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 and then red. Red is minus. Actually, minus is not connected here at all. But in Eurorack, it's a convention to mark the minus 12. So I took the faceplate off, and now I can just put one point here. Check that it's aligned correctly. This is looking pretty good. I can now solder the rest. Now maybe I can show you what is a bridged soldering joint. See, these are bridged, not good. What I can do now is I can put my soldering iron in the middle and lift it up, and it will just clean it. Again here, put it in the middle, lift it up, and it cleans it. So these are now disconnected, looking good, and we have now a Eurorack power connector. Awesome. Let's connect our switches. So we have here one switch. Where is the other switch? So 2 switches. These are what we call on, off, on switch. We have 2 of them. We're going to place them right here. 1 and 2. And then we're going to turn to the other side. Hopefully they're not going to fall. That's not too bad. And the way that we solder these is, there's a trick to it. You need to solder only one of the pins first. So I'm just going to press and solder this pin. And then I'm going to press and solder this pin. And once these are soldered, and it's not perfect, you can see this is not finished. That's okay. This is just to hold it in place. And now I can look here and see that it's certainly not aligned. Because I soldered only one pin, I can warm it up, press it in, make sure that all the little red legs are flush to the board. Do the same thing with this one. Let's see. Warm this up. And then straighten it. Oh. And now when it is flush from both sides, I can go to the other side and solder this pin, and then repeat my, oh, you can't see it here, and then repeat this one as well, because I was moving it, and then also here, solder this pin, and then warm this up so it falls into the hole. And there we go. We have all the components soldered. We have here switches, we have here knobs, we have here faders, we have here our jacks, we have our touch sensor. Let's zoom out and let's place our microcontroller right here. So I'm double checking that my last pin is here. I'm going to press it in. This is looking solid. We didn't make any mistakes. We have a Eurorack connector. We have all the components. All we need to do now is to put our faceplate. We can turn off our soldering iron. And by the way, when you turn off your soldering iron, this is something I learned on a tutorial from Weller, the company that makes this soldering iron. Let's maybe turn on the light. And what you want to do before you turn it off, is to put some solder on it, clean it, put a bit more solder, and then when it is with some solder on it, like this, then I put it and turn it off. The reason that we do this is because we want to keep the tip from oxidizing. So the tin allows it to, it basically covers it and protects it from oxidation. Okay, now I'm going to put this spacer right here. The reason that I do it after I soldered everything is because it is very, very close to the fader, and if I put it first, it might bend. The fader might be in a bit of an angle. So we do this right after, which is a bit annoying, but definitely not the end of the world. Okay, so just gonna put my screwdriver here, and this is not going anywhere. I'm gonna take the other one, again, put the bolt inside, take the spacer from here, press on it, and there we go. Now, all we need to do is to put this on, take three more bolts, 1, 2, 3. So everything is turning correctly, everything goes up and down correctly. Me happy. Very good. Now what we can do is connect this to the computer, and everything should be working. I'm gonna connect it right here. I see a blinking LED. That means that this is a new microcontroller with no firmware on it. If I'm gonna take this black thing out, it's kind of bothering me, and just press boot, reset, then it should stop blinking. That doesn't work. That's a first. Boot reset. Okay, there we go. Boot reset. Now we don't have a blinking light at the top. And we can go to the browser and GitHub. Yeah, so we have here our programmer, connect, and you can see here DFU FS mode paired, connect. Now look what happens if I press reset and it's blinking again. So see, now it's blinking again. Then here it says a different thing. It says Daisy Seed built in. This is not what we want. So I'm gonna go back, I'm gonna do boot reset. I don't see a blink. Then I go back here and I see DFU FS mode paired, connect. Now I can choose here my file. Let's just choose the string, or actually base, that doesn't really matter. So let's do base and program. Erasing, and in a second it's going to upload the program into our Daisy. There we go. It says here done. Let's go back here. This now has the Daisy on it. If it works okay, it should just play sound. So let's see. Anything DIY, you know, it can happen that we made a mistake. So yeah, maybe we double check a little bit before and we see that we don't have any shorts. It's very important to do that. If it's your first time soldering, then make sure that you don't have any shorts. Again, it's a really easy build, but yeah, it's working. This is my filter here. Cool. In the bass, by the way, I didn't talk about the controls here, but if you hold the H here, let me zoom in a little bit. If you hold H, then you can change the amount of the envelope going into the filter. So this is the filter, right? It's a Moog ladder filter. And if I have here a frequency, that's this one. And then I have here the second oscillator. This is this one. And then we have the same thing with arpeggiation that we had here before that we mentioned. So if we do this, let's maybe turn off. Okay, so this is the basic control, but if I hold H, I can add the envelope into the filter. So every time that the envelope triggers, it will control my filter. And this also pairs with the resonance, which is also on the same fader. So if I do T and I bring this up, I bring resonance up. And then magic happens. Extra magic if we hold T and we bring this up. We have a built-in reverb. This is pretty much it, guys. Let's see. Yeah, let me see if I have more questions. If you have any questions, please ask now. We're about to finish. Thanks so much, Gary. It's good to see you here. Yeah, we're pretty much done. The only thing that we need to do now is obviously connect the, I mean, if you want this to be connected to Eurorack, remember that this is the red. So connect it here. And we can connect these spacers and then put the faceplate, back faceplate on it. So I'll show you, this is a back faceplate. This one I used for the looper. You can write here what firmware is, and you can just simply put this in. I think you should be able to do this on your own. The only thing I would maybe mention now that we can do together is let's have a look at connections. And then we can wrap up. Let's put this like that. And I'm gonna, every time that you use one of these, you want to disconnect your power because they are going to make a short. This multimeter, we'll need to press on it here to make it beep. Some of them don't need to do it. What I want to do is to do a continuity test. And I want to just show you that the Eurorack connection, let me see if I can do this both together. Yes, good. Focus, great. Okay, so I am disconnected. I'm gonna beep. And what I'm gonna check now is that my ground here is connected to pin 48. See? So 48 is connected to ground. This is also connected. This is also connected. This is internally connected to here. These three connected to here. And then 47 is connected to here. And it's not, definitely not connected to any of these. So I can check this before I connect it to Eurorack, just to double check that this is the only pin that's connected directly into pin 47, because that is the one that can take up to plus 17 volts. So the 12 volts that you have on Eurorack, you can totally put it here. You could also take a battery like these right here, and you connect them also there. You can connect a 9-volt battery. Yeah, this is pretty flexible, pretty awesome. So yeah, then you can see that the red here is not really connected to anything. That's because the Daisy doesn't need minus 12 volts. In Eurorack, we need minus 12 volts because of the op-amps, a lot of analog synthesizers that require minus and plus. But because this is completely digital, we only have the plus 12 volts. We marked here the red because we need to know that the red cable, the red side of the ribbon cable should be connected here. And other than that, we're pretty much done. Thank you so much for watching. Thank you for supporting the initiative. Again, if you want to join the membership, you can go on the website, click the membership button, and then subscribe right here. This is really appreciated. The only way that we can do this stuff is if you buy from our shop or if you support us through the membership. If you're developers and you want to develop your own ideas using one of our boards, this is also super helpful for the community because then we have more firmwares that we can share with the world. So if you're into open source and you want to build this community and be part, core part of this community, this is your opportunity. Just to give you some context, Vlad and Nick and Lucas and a lot of other people who are working to make these things possible, they do it in their free time. We all do it in our free time, and everyone who supports, you know, helping on Discord, answering questions for beginners, or buying something from us, or making a tutorial or whatever, is really, really appreciated by all of us. Thank you so much. And I'm going to see you in the next live stream, which is going to take place next week. I'm going to send an email about it to maybe choose a different date. I don't know if, not a date, but a day. It would be good to know what day is best for you. Maybe write in the comments. I'm also going to write an email so we can choose together which day is the best for everyone and which time of the day is best for everyone to do these live streams. The theme for the month is designing a bass instrument. So you can go on our GitHub and get acquainted with, let me see if I can get there quickly. Get acquainted with all these different classes that Vlad wrote and designed meticulously. These are not here, but sorry, Daisy Duino and then bass. So if you go to Synthux Academy, Simple Touch Instruments, and Daisy Duino, you're going to see Touch Bass. And you can go into each of these files, learn what they do, and we're going to break down the design in the next live streams. So in the next 3 live streams this month, we're going to break down all the design of the bass instrument. And then we really hope that some of you are going to get your hands dirty and start to program cool bass instruments. With that being said, thank you so much for joining, and I'll see you in the next video.